All right, so we start on page 77, but this week is a little bit unusual. We had a snow day, and also I'm going to be out of town for the rest of the week. So we got to talk about what this week will look like. So first of all, there's a very important holiday on Thursday that is not celebrated as much as it should be. Anybody know what's happening on Thursday? It's Pi Day on Thursday. Pi 3.14, right? March 14. Celebrate responsibly. I'll say that. So it's a great holiday, but be responsible. So this was a scan or a photo, I guess, of somebody leaving a tip at a restaurant, and they came up with a way to use pie in their tip, which I thought was pretty good. Isn't that nice? All right. So there was something else. That's that, right? So a couple of things. First of all, so today we talk about applications of systems day 2. It's our second day on word problems. Last class we did certain kinds of word problems. Today we'll do 2 new kinds of word problems. Our next class is going to be test number 1. So what the snow day did is it took away Friday, which is taking away our review day. So it's a little bit awkward, and I don't like taking away our review day. But I sent this email out where I explained why I felt like it was kind of justified to do it. So this is in your email. We're not going to read it to each other now. But essentially, there are a ton of resources available to you as you prepare for Wednesday's test. And they're available to you even if we didn't meet to talk about reviewing for the test. What would have happened on our review day is you would have spent a lot of time doing the sample test problems from the packet. Well, you should still spend that time doing them, but you have a PDF with the solutions, you have an answer key in the packet, you have YouTube videos of me going through every single one of those problems. So I'm hoping that folks will spend some time outside of class looking at those resources. But just to be really clear, so here's what this week looks like. Come on back. So on Monday, we're covering the last section of material that's on test number 1. Wednesday is test number 1. Our window is a little bit different. Jen is one of my colleagues here in the math department. She is going to be here to give you your test on Wednesday. Normally we do 12:10 to 2:10. Jen is able to do 12:30 to 2:30. So show up early if you can. I'll say that the test is a little bit longer than each of the quests have been. So you really do want to make sure you have as much time available to you as possible. So see if you can get here ready to go for a 12:30 start. Friday is a normal class with new packets, which I've put on the table. So everybody should grab one of these new packets. Everybody have one? So we're not going to look at them today or Wednesday, but Friday, first thing, you are going to start with the new packet. All right, so make sure you have that with you on Friday. And another one of my colleagues, Jessica, is going to come and teach class on Friday in my absence. All right. So what that means is you're going to take the test Wednesday. When are you going to get your graded test back? Monday when? Monday after spring break, because the following week, this week coming up, is spring break. Right. So it's good. It's going to be a week and a half before you get your test back. I apologize. It's just, yeah, I apologize. I'm physically not going to have access. Yeah, I'm going to be away for a bunch of the time. Yeah. So it'll be a delay between when you get your test back. I'm sorry. I'm not starting my spring break early, if that helps. I'll be working, just won't be here. So that will happen on Friday. Drew. For a little bit of time, not forever. Definitely for the rest of the semester, but after that. Yeah, Michelle. The college is definitely open next week. So all of the offices will be open, the buildings will be open. Everything is happening next week except for classes. Yeah. So speaking of things that are happening next week, here is some information that you might find helpful. The GCC Financial Aid Office is ready to help you fill out your FAFSA form next week. FAFSA is the financial aid form for the federal money, and apparently it's quite complicated to fill out, but if you just drop in Monday, it's during spring break, but this coming Monday, anytime between 9 and 3 in East 144, they will help you fill out your FAFSA form. So write that down if you have any plans on maybe coming in next Monday. They will also be available on Tuesday of next week For drop-in hours, that's going to be in Hadley, so that might be better for some of you and worse for others. In most cases, it takes 15 minutes or less to file a renewal FAFSA. So if you've done it before, it's 15 minutes. If you've never done it, less than 30 minutes. So it's not a big time commitment if you have people around you who know how to fill the thing out, but it's very complicated. So drop in if you are able. The priority filing deadline is May the 1st, and apparently it could be like $1,000 difference if you don't file until after the deadline. That's what one of my students told me this morning. So any questions on that? Okay, so let's get started then. Yeah, so we're here on page 77. One quick announcement about the homework. So there is a homework assignment that I'm going to assign at the end of today, but I want to make sure that you are focused on studying for the test and not distracted by a homework assignment. So do as much of the homework assignment as you feel you need to prepare for the test. But really, between now and Wednesday, you should be focusing on preparing for the test. So I'm not going to collect the homework assignment that I'm assigning tonight, okay? I'll never collect it. Evan?
I'm sorry, but we have some
Good question. You didn't miss it. So normally I allow people to turn some late homework in at the start of the quest or test, and I will, but I won't be here to do that. So if you could give it to me the Monday right after break, I'll take it. Good question. Yeah. All right. So I think that's it. We'll go ahead and jump into number one. And while we're still on speaking terms, Drew, number one. Okay, so let's see if we can answer this. So 15% of those cups is sugar. So what do I do to these two numbers? What do we do? We multiply. Everybody feel we should multiply these two things? So we take 15% and we multiply it by the 20 cups. Yeah, let's get that 15 as a decimal, so it's 0.15. Remember, the decimal goes 2 places to the left. And then we multiply that by 20. Yeah, 3 what? 3 cups. 3 cups of sugar. Okay, so that's how we can figure out how much sugar is there. Let's go to Katrina for B. Okay, try the same technique to answer that question. I get 3.5, is that all right?
Yep.
Any questions on this so far? Okay, part C. We're back to Aaron. Okay, so we had 20 cups of regular Kool-Aid and then another 10 cups of regular Kool-Aid. We're not looking at the sugar, just the liquid. So how many cups of Kool-Aid? 30? All right, so 10 plus 20 is 30. 30 cups of Kool-Aid. Part D, Sebastian. Okay, how do we answer this question? How much sugar is there? We add what to? We add the 3 and the 3.5, right? We know how much sugar is there. So we take the 3 plus the 3.5, and we get 6.5 cups of sugar. And then we'll go to the next page and bring it all together. Part E, Joe. Okay, so let's find a percentage Now, there are a lot of different formulas you maybe have seen for percentage, but the basic one is something like this: part over whole. Anybody, does that look familiar at all for percentage? You take however much stuff is special and you divide by the total. So I want to know what percentage is sugar. So in my case, I've got sugar over the whole. The whole is the Kool-Aid. How many cups of sugar? 6.5. How many cups of Kool-Aid? 30. If you type that into your calculator, you'll get a decimal, which we can then write as a percentage. What decimal do we get? So I'll write it as a 0.216 first, right? Because that's what the calculator says. Over. Okay, so then maybe 217. Round that up. And if we want that to be a sorry, it is a decimal. We want it to be a percentage. Move that decimal point 2 places to the right. 21.7%. I don't think any part of today I'm going to ask you to do that calculation. So if the part over whole is confusing, or maybe you haven't seen it with those words exactly before, don't sweat it. This is really just for us to think about what's going on. 21.7% of the mixture is sugar. That's what we're finding. What was the percentage of the initial Kool-Aid? What was 15%. And then the really sweet stuff, 35. If we're pouring things together, it feels like we should add 15 and 35. That's 50. That's not right. In fact, the answer is less than 35. Are you surprised? You had 35% sugar, then you added 15% sugar. Isn't that more? Yeah, we actually diluted it by adding, right? Because the one stuff was not as sweet as the other stuff. So, yeah, and there were more cups of the less sweet one. So that 21.7 is actually someplace in between the two percentages. Yes? 15%, 35%. That's somewhere in between. It's not perfectly in the middle because one of them was 10 cups and the other was 20. So it's actually weighted more towards the 20 cup than the other one. But I guess what I'll say is if you have a 15 and you have a 35, you can mix them in sufficient quantities to build any percentage you want between 15 and 35. If you want to build a percentage right in the middle of 15 and 35 is 25. If you want a 25% solution, mix the same amount of each one. Yes? If you want a 20% solution, then you better add a lot more 15 than 35. If you want 20, which is very close to 15, you better add more 15 than 35. So this is the idea, is that we can build any percentage that we want between 15 and 35. That's what we're going to be asked to do. All right, so we're going to organize the information above into our table here, and then we'll actually do a tough problem together. So last time we had a table that had 3 different rows and 3 columns, and then we filled in. So it's the same idea here. How many cups of Kool-Aid were in the regular? 20. How many were in the daughter's Kool-Aid, which was very sweet? It was 10. And the total? 30. So far, so good. Percent sugar for regular? It's 15. I'm always going to write this as a decimal. I automatically write it as a decimal because I'm going to be using that number. And I really want it to be 0.15 instead of 15%. How about for the daughter? It's 35, so I'll do 0.35. Now it turned out we did a lot of work and we found the number that goes in this next box. What percentage was the total? It was 21.7 or 0.217. I'm not going to fill it in. We never fill it in. We just happen to do some work so we could find it. But at the moment, we'll just leave that as a blank. Okay, and then amount of sugar. How did we find how much sugar was in the regular one? We multiplied. Didn't we do 20 times 0.15? So I'll put over here 20 times 0.15, and that worked out to 3 cups of sugar. And then the same thing down below, we multiplied across. And I'll say that I'm hoping that what we just did reminds you of the tables we filled out last class. I know it was a while ago because of the weekend and the snow day, last Wednesday. Didn't we go across? I thought what we did was we multiplied these two numbers and it gave us the last column. Last class, Wednesday. Yes, you made equations by going down, but you filled in the last column by going across. Yeah, multiplied, I think in one example, I don't remember exactly what it was, but it was like the number of pounds of, oh, was it candy? Yeah, you had cheap candy and expensive candy, and we knew how much each of them cost per pound, and we multiplied straight across to find the total cost of each of them. And then we did another example, I don't remember what that one was. It was another case where we multiplied, oh, it was interest income. We had two investments, one of them had a high investment, high interest rate, the other one had a low, multiplied the principal times the rate, and it gave us the income from interest. So it's the same idea. So let's see if we can apply this idea down here. Oh, and I guess we could fill in the 6.5 if we want to. So let's try number 2. We'll go to Dan in the back. Okay, so let's see. I'm just going to underline two things. We have a 20% antifreeze solution and a 35% antifreeze solution, which is basically like the sugar inside of the Kool-Aid. 20% of this first liquid is actual antifreeze, the actual antifreeze chemical. The rest of it is basically water. So antifreeze is a really, really strong chemical that you're not going to put in your car undiluted. So you add some water to it, and maybe you have a liquid that's 20% antifreeze, or you have one that's 35% antifreeze, right? Everybody understand what we're talking about? So the antifreeze is a specific chemical. We just say, take a look at that, like hand me that jar of antifreeze, but really the antifreeze itself is a strong chemical. Most of what's in the jar is water, and this chemical is diluted inside of it. So we got a 20, we have a 35, but for this mechanic's needs, he needs a 25% solution. Why is it reasonable to think that we maybe could come up with ways to add some of each kind and build 25? What's special about that 25 that's going to make this possible? That's exactly it. 25, the thing we're trying to build, is somewhere between 20 and 35. We can build any percentage that we want between 20, the weak stuff, and 35, the stronger stuff. And that's what we're going to be asked to do in this question. And maybe you're not so excited about making different concentrations of antifreeze, but doctors and nurses do this all the time. If you have a drug that's going to be injected into somebody, right? We've got this IV going into the patient. And so what percentage of the drug you need depends on the patient, right? Maybe some patient needs a very high percentage of the drug, or another patient just needs a little bit of the drug. Well, the doctors and nurses can't just order, okay, give me a 7% solution of this, or give me a 13% solution of this. They come in just a few fixed quantities. So you just say, all right, give me some 20, and give me some 30, and give me some 10. And then they got to do some work to build the percentage that this particular patient needs. So it's the same kind of problem. All right, so first step, as always, is to define the variables. And as always, I go to the very last part, the last question. How much of each solution should be in the mixture? Those are what our variables are going to represent. How much of each kind of this chemical? So I've got a low and a high. So how about I say L equal the, what are we doing here? This is in quarts, thank you. L is equal to the number of quarts of the 20% antifreeze. I'll say the 20% solution. It's probably better. So I've got the low solution, the low concentration is 20. And then H can be number of quarts of the 35, the high. Okay, so part B, we're going to organize the info in a table. And I think somebody had asked me the other day, am I going to provide the table on the test? And the answer is no. The answer is still no. So we'll do a few of these, and then hopefully you'll start to understand it's always the same basic setup. These problems, the candy problems from last class, they all look quite similar. So make sure you practice to the point where you can make a table. Making the table is a big part of the solution. So we've got amount of solution in quarts, we've got a percentage, and then the actual amount of antifreeze, which to me sounds very familiar. It sounds an awful lot like amount of Kool-Aid, percent sugar, amount of sugar. Okay, so amount of solution in quarts. For the 20% solution, we came up with a letter. What letter did we choose? We choose L there. For the 35% solution, we called that one H. And then for the final mixture, this is actually in the problem. How many quarts of liquid are we looking for when all is said and done? Is 12, right there. So as we want to mix 12 quarts. 12. Okay, percent antifreeze, this is the easy column. Oftentimes that middle column is the easy one. What percent antifreeze is the 20% solution? 20. But we're not going to write 20. You don't need the 0, but I'll put it. Okay, right down below, what percent is the next one? 0.35. Should I add them to get the total? No, it's just not how it works. In this case, the total is given. Yeah, the total is right here. We're trying to mix a 25% solution. That's the goal. So we put it, 0.25. And then the whole idea of the table is that to find the last column, you multiply straight across. Multiply the first two columns, it equals the last column. So in the top row, it's 0.20 times L. Next row, 0.35 times H. And the last row, we're going to get a number. You just multiply. 12 times 0.25. 3. So we'll pause and give people time to catch up with the table. Any questions on the table? Okay, then let's see if we can get our two equations out of this. So what Katrina was saying earlier is that to get the equations, we look in columns. So in this first column, what do we get? What's that? Yeah, so the first equation we're going to get from L plus H equals 12. Yes? Add them up, I get 12. So that's the first one. And then the next equation comes from the last column. It's the same pattern. That's it. So it's easy enough to just write that down because it's the pattern. It's harder to really understand what that equation says. This 0.20L tells you how many quarts of pure antifreeze, the chemical. How many quarts of that chemical do you have? Well, I don't know. Depends on L. But whatever L is, 0.20L tells me how much of the pure chemical I have from the first bottle. This thing is how much pure chemical I have from the second bottle. When I pour them both in, I know when all is said and done, I'm supposed to have 3 quarts. That's what I need to have when all is said and done, because it was going to be 12 quarts at a 25% concentration. Got to have 3 quarts when we're done. So you add how much actual antifreeze chemical you have from the first bottle You add that to how much chemical is in the second bottle, the total had better be 3 quarts when all is said and done. Okay, so then solving these equations, I'm actually content right now to not even finish this problem because this problem is now like a straight algebra technique from like 2 classes ago, from a week ago, when we learned there were 2 methods we had, substitution and then elimination, right? So I'm just gonna stop this one because I wanna make sure there's time for people to practice the new thing. The new skill for today is to get to those equations. Then it's the old skill. I'm not saying it's easy, but I'm saying I wanna move on and make sure we practice the new skill for today. One last thing I'd like to say, I'm not thrilled having decimals in my equation. You guys remember what I would do to that black equation? Yeah, so you could do fractions. You could also multiply by 100. If you multiply everything in this equation by 100, so times 100, everything, 100 moves the decimal place 2 places to the right. That becomes 20L plus 35H equals, it's easy to forget to multiply that by 100 as well. I would deal with that equation, no decimals. Okay, so I think that's it for this page. So when we're ready, we'll move to the next page. And we'll take a look at number 3. We'll go to Michelle. Okay, so let's think about this rate times time equals distance. It might not be a formula that you just have on your brain all the time, but it's one that you know. If I tell you I'm driving at 60 miles an hour and I'm traveling for 3 hours, how far did I go? 180 miles, right? What do you do to those numbers to find the distance traveled? You multiply them. So that is just an example of this rate times time equals distance. 60 miles an hour times 3 hours, 180 miles. So you know it even if you don't think of the formula. Okay, so now we've got this person, Irma, who's flying her plane, and she's just going to Saratoga, New York, and then coming back here. And it's 450 miles each way. And on the one hand, she's going with the wind, and that takes her only 3 hours. But when she comes back against the wind, it takes her quite a bit longer, almost twice as long, actually. It takes 5 hours, all right? So what we're gonna figure out is how fast she would go without any wind, and also how strong the wind was, all right? So let's give this a shot. In order to define the variables, where do we look? The last sentence. The last sentence tells you what the variables should be. Find the speed of the wind and the speed of the plane in still air. Those are your variables. You don't really even have to come up with them out of the blue. They are exactly what we are being asked to find. So we've got wind and we've got plane speed. So how about we let W equal the speed of the wind? And it seems like miles per hour is going to be the right unit here because we have miles and we have hours. And how about we use P for speed of the plane? I'm going to add this phrase at the end, in still air. If there were no wind, I want to know what the speed of the plane is. Okay, so what's the first thing we noticed about our table? Yeah, there's only 2 rows here instead of a third one. There's no total row. Okay, so it's a little bit different. Let's fill in. The trip to Saratoga with the wind, we're going to fill the time in. That's the easy column. Every time it seems like the middle column is the easy column. With the wind, what was the time? 3 hours. Against the wind, 5 hours. Okay, here's the tough part, is filling in this first column. The trip to Saratoga with the wind, I want to know what her rate was. Now, normally we would just stick a letter here. What letter would you put here? Put W? I mean, it feels like P is her speed, right? The rate at which she was flying is P, but P is if there's no wind. And there was some wind in this case. It's actually not just a single letter there. It is. Let's just do a quick example. Suppose, for example, that the wind speed was 50 miles an hour, and the plane speed normally is 200 miles an hour. That's in still air. She would normally go 200 miles an hour. If the wind is perfectly at her back, if it's pushing her along, how fast is she going? 250, right? She would normally go 200. Then she's got this extra burst of 50 miles coming from behind. So she would be going 250 miles per hour. How about when she turns around and goes directly into the wind? How fast would she go? Only 150 in that case. She would normally be 200, but she's being pushed by a 50. So her effective speed slows down to 150. So what do we do to these two things when the wind is helping her? Is we add them. So then what goes in this first column is the add, P plus W. That's how fast she's going. It's whatever the sum of the wind speed is and the plane speed. And what do we do with these numbers when the wind is hurting her? Is we subtract them. W minus P or P minus W. Only one of them is right. It's P minus W. If it helps, which one did you subtract when you had 250? You did 200 minus 50. You did P minus W. So that's what goes right there. So that's a little bit tricky the first time you see it, but now you've seen it, and you'll see another one in the homework tonight or the group activity, depending on whether or not you get to it. And you'll start to see, oh, every time we have wind and the plane speed, we add them together when it's the good direction and subtract them when it's the bad direction. But I'm hoping we buy it, looking at the numbers in the top right there. Okay, to find the third column, well, it says distance. Well, what have we done every time we had a table to find the third column? We multiplied. It's still multiply. Why is it multiply? Because right here it says rate times time equals distance. It's exactly what we have. Rate times time equals distance. So we multiply. So in here we will put 3 times P plus W. You need to bring parentheses in. Multiply those two together. 3 times P plus W, 5 times P minus W. Yeah, you can, and we're going to use the 450 both times. I'll encourage everybody to multiply across to get that third column, and then come up with the equation using the number in the problem at the end. It's not wrong to just put 450. This is correct. And it's also correct to put 450 here. But we don't have an equation yet until you see multiplying is the same as 450. Okay, so then our two equations, that's exactly what Evan was getting at. The total distance traveled, that first green thing, 3P plus W. All right, so that was the trip out to Saratoga. What was that total distance as a number? It was 450. So this 3P plus W must be 450, has to be. That's the distance that she flew as an expression, 3 times P plus W. That's how far she went. She went for 3 hours at some unknown speed. We multiply them. That gives us how far she went. But on the other hand, she came back. And the distance back is the second green expression over there. 5P minus W. What was the distance she came back? Also 450. Those are our two equations. Questions on writing the two equations? Okay, so I do want to go a tiny bit further with this one, even though, again, technically this is now just like pure algebra to solve either use substitution or elimination. But I want to highlight that there's an easy way and then there's the hard way. I'm hoping on the test you pick the easy way. So first of all, couldn't I just say that these are equal to each other? Because one of them is the distance out and the other one is the distance coming back home. Aren't they equal? And so it's perfectly correct to say that they're equal and just write this one equation. And forget the two green ones. That one equation is true. But if it's one equation with two letters in it, that's not enough, right? We have two letters, P and W. You need two equations if you're going to find those two letters. So while the red equation is true, it's not helpful. We need two equations. So yes, they're equal to each other, but the 450 is really important here. I need that in order to answer this question. So I'm not going to write that red equation. The other thing that I'll say is that it is tempting and fine to do this. Don't write this down. What did I do with the 3? Distributed. So that's correct, yes? And then you can distribute the 5 over there. If I'm going to do substitution, that means I need to solve this equation for one of the letters, maybe that one. Why am I not thrilled at this point? We're going to have fractions. Do we see it? If you need to solve this first equation here for P, okay, you subtract the 3W, and then you divide everything by 3, and we have fractions. Is it any better if you had solved for W instead? No, we still have to solve for W, and we still have to divide. Yeah, things will cancel in this case. I want to do something to cancel before we even do that. So I don't want us to write this, even though it's correct. I'm going to put a red line through it. That's not the way to go. The way to go first is to take this equation and divide both sides by what number? 3. Let's divide both sides of this equation by 3. Anybody here play chess? I've got a few chess players in the room. I don't know if anybody has ever watched like the notation for like a game that's already been played. Like there's a standard chess notation, and I haven't looked at it in a long time, but you know, it'll say like you take the knight and you move it to like A3, or like I'm just making something up, so that probably isn't even like legitimate, but it just tells you like what the moves are, right? But if there's a move that's like a particularly good one, like the person writing the notation is making some judgments. And if there's this move that's like, this turns out to be the killer move, even if the game doesn't end for another 5 or 10 moves, anybody know what they put, what symbol they put? So it's actually an exclamation point. So if you make a move that is just, that's the game, even if it's not clear to the opponent yet that that's the game, you'll see an exclamation point at the end of it. This divide by 3, that's the move of the game right there. So here's what happens. If we divide the left-hand side by 3, the 3 cancels. That's why you did it. You just cross off the 3, and all you get is P plus W with nothing in the front. Equals 450 divided by 3. It's just a number, 150. I'm so much happier with that equation because now we don't have all these coefficients, all these numbers in the front of the letters. See if you can do the same thing with this equation. Divide both sides by the right number, and then write the equation that you get at the end. What's the right number? Or what should we divide by? Divide by 5. So we just get P minus W equals 90. These two equations, way easier to solve than the first two equations. Now, I haven't looked at your test in a while. I wrote it a long time ago, and I intentionally try to not think about what's on the test because I never want to teach to the test. But I'm pretty sure that my memory reminds me that there's going to be an opportunity on the test for you to do this kind of thing. I'm not saying there's one of these airplane equations. There might be, I don't remember, honestly. But what I do remember, I think, is that there's a system of equations you'll get out, like the green ones, that you can distribute, and that's fine, but you're not obligated to distribute. And life is going to be so much better if you divide by that magical number sitting in the front. Do that first. Okay, so let's finish this one up. I'll write the two equations down here. We'll just go all the way to the end here because we're so close anyway. To me, these equations are set up perfectly for, it's either substitution or elimination. Which one is this one begging for? Is it substitution? The substitution means you got to solve for one letter, which is a little bit of work. It's not a lot of work. But what can I do with these equations and something good happens right off the bat? Yeah, what do we do to eliminate that W? That's right. So if we just add those two equations, the W's will just disappear completely. It couldn't be any nicer. So add the two equations. How many P? 2P. What happens to W? Cancels. Add over here. 240. And now we have an easy equation. And once you know that P is 120, you can plug into either equation. I'll plug into the first because it has a plus sign instead of a minus sign. Instead of P in that first equation, what can we put? 120. Plus some W equals 150. How much is W? 30. So normally the speed of her plane is how much? Normally it's 120. The wind is 30. So when it's working for her, she's actually traveling 150 miles an hour. Against her, only 90 miles an hour. Any questions on this one? Okay, so that is the end of the new material for the tests. You are going to see something like either a, what was the first kind that we did today with the percentage, like a mixture type problem with a percentage, something like a speed type problem here. Something else I can share with you that I remember now about the test is that you're going to have some choice on the test actually. In terms of the word problems, you're going to do 2 word problems from me, but there are going to be 4 that you're going to pick from. So I'm going to say do one of these 2 word problems, and I'm going to say do one of these 2 word problems, and you choose, right? And I also think it's probably okay to say that they're kind of divvied up just like the 2 days we've spent on this. Last class we talked about, you know, like the candy, like the total value problems, you know, sweatshirts, and I don't know what the other thing is we were selling, concert tickets and things involving money, right? Did a bunch of things involving money last time. And then there's this other kind. Which involves either the travel or the percentage. Good? No, you do all 4. That's more work for me. That's bad. You lose credit if you do all 4. All right. Okay, so that is that. So on the next page, what you're going to do is start these problems right here. So we have a good 25 minutes today to get as far as we can. How about we, again, I'm going to assign one problem to each table, and that table will put the problem up on the boards. But there's enough time for each table to do several of them, all right? So where did we start? We started last time there. So we're going to start here. You guys are number 1. This table is 2. You right here are 3. In the back corner are 4. You guys are all doing number 5. Okay.